All right, let's talk about the Elastic Stack and how we test and release that one. So I'm going to talk about lots of things about testing from a developer perspective, because that's what I'm basically doing all day long. Before we get started, who of you knows Elasticsearch, Logstash, or Kibana, any of those things? Okay, that's great, because I'm not going to explain a lot. And yeah, one of the things which I haven't seen a lot during this conference is also talking about releasing, which I think is super important, because code which you don't release doesn't really exist from a customer perspective. So we'll spend a fair share of time about that as well. And yeah, we have a fair number of slides to cover, so sometimes I might be going too quick, but if you have questions, I'm going to be hanging around after the keynote as well, so if you want to talk to me, just come up and ask whatever you want. All right, quick introduction. Hi there, I'm Alex. I live in Munich. It's my first time in Russia. I made it through all the visa dance you have to do in order to get here. I work on Elasticsearch. My main task currently is working on one of the commercial plugins, the alerting one. And yeah, I'm interested in search, so I'm running the search meetup in Munich. And I joined around 2013. I think the most interesting part about my company, or the company I work for, it's not mine, is basically we are fully distributed. So we have a couple of offices, but you don't need to go there. I've never seen an office. I've always been doing home office since I joined, which is great because I can't imagine sitting in an office now anymore. And yeah, the company itself makes money by offering support subscriptions, training, consulting, and by offering the products we basically, which are open source, we run them as a service for you. And this is important because this also needs to be part of testing and release strategies later on. So what is the Elastic Stack? Just to make sure everyone is on the same page, we basically have the open source side of things, which is something like Elasticsearch, Logstash, Kibana, Beats, and the so-called clients, which are basically sort of a small layer on top of HTTP clients to communicate with Elasticsearch, written in their respective languages, like Ruby, Python, PHP, JavaScript, Perl, or Java. And then on the other side, we basically have our commercial products. One is called XPack, which is basically called Extension Pack. Then we have Elastic Cloud, where we run everything as a service, Elasticsearch and Kibana. And we have something called Site Search and App Search, which is basically some sort of enterprise search, which is just leveraging the products we're using. And the last one at the bottom is called APM, which is partially open source and a couple of commercial aspects. So all of this is the Elastic Stack, and this means all of this is basically written in different languages. All of this has different build mechanisms. We have Elasticsearch written in Java. We have Logstash written in JRuby and Java. We have Beats written in Go. We have Kibana written in JavaScript and Node. We have the application performance monitoring written in Go and the instrumentation agents written in their respective languages. We have our commercial stuff written in C++, Scala, Ruby, all of the above. We have tooling. We have Perl scripts, which builds our ASCII-doc documentation and puts it on the website. So pretty much of everything. We have built tooling around. We have Gradle. We have the clients I just mentioned in their languages. We have infrastructure code, like AWS Lambda, Kubernetes stuff, Vault, Ansible, Terraform, Docker, Jenkins, JGB jobs. So we have a lot of stuff. And this also means we have different build systems. We have different release mechanisms. And we can't do anything like continuous delivery, right? We can't just tell you, oh yeah, please use this commit hash and go from there. We have to release a version, and we have to make sure that those versions are compatible with each other. And in the past, basically all of those products were released separately. So the Elasticsearch developers decided, oh yeah, let's release Elasticsearch. And then the Kibana developers decided, oh yeah, let's release Kibana. And this led to this wonderful slide from Elasticon, where you basically have this compatibility matrix from hell. Except for the people working at Elastic, no one really knew which version was compatible with which other version. And so at some point in time, we basically decided, okay, this is not feasible. So we basically took all of the burden on our side and said, we're going to release all of the software we have at once. So we basically, when we release version 5.0 from the whole stack, we release Elasticsearch, Logstash, Kibana, all the things. which is great because now you know that everything which is in version 5.0 is compatible with each other. But it also means on our side, we have like a really much bigger burden to make sure everything works with each other and everything can be released at the same time. And I'm going to talk about this a little bit more later. Time for something a little bit different. How do we test Elasticsearch? And I think there are a couple of interesting things. Of course, we have many different tests. So if I run the whole test suite on my notebook, which is 3 years old, I think it's easily taking 1.5 up to 2 hours to run every test. But of course, you should test the most things in life as unit tests, right? And only go to the slow running tests over time. So we basically have unit tests up and running. As you can see here, it looks like regular Java, that's no surprise. The interesting part might be that we're extending from ES test case. And if you go further up the chain and we take a look at ES test case, you can see that's quite an annotation party. We don't need to get to that. The interesting part is it's basically based on a Lucene test case. Why do we do this? If you take a look at the top, we have this nice little thing called a reproduce info printer here. The reason for this is that we use a feature called randomized testing in Elasticsearch, which basically means you have the ability to create random data, like give me an ASCII string with a length of 10 or something like that, and you get back an arbitrary ASCII string or an arbitrary UTF-8 string. And the important part is if we return random data, we need to make sure we are able to reproduce this. And the idea of reproduction is basically that you start with a certain random seed, and based on this random seed, all of those random values are generated. So it allows you to create reproducible tests, which still contain random data when you run them 10 times in a row. And on top of that, we have another small feature. Just imagine that this is an annotation and there's an add over here. And this one allows us to detect lingering threads, which basically means if your tests are starting a thread or a thread pool and you're not closing it properly, we will basically fail the test because you're not closing your resources properly. And the whole Lucene test case has a couple of those features. And we want to make sure we make use of that. So those are unit tests. The next kind of abstraction we have is something we call an ES single node test case. So we are basically starting an Elasticsearch instance as part of our unit-based test. One of the things is that Elasticsearch uses Google Juice internally, which is a dependency injection framework. So for some tests, we basically have to make sure we are starting an Elasticsearch instance in order to be able to access those wired classes. And this is exactly what you can do with a single node test case. And on top of that, we have something called the ES intake test case, which basically allows us to start several Elasticsearch nodes within a single test. So what we can do with this is basically, please start me a cluster which consists of 3 nodes, fire it up, and then run certain tests to make sure that distributed features are working as intended. That sounds really nice, but the problem is, in production, when you run Elasticsearch, you basically have one JVM mapped to one Elasticsearch instance. And in our tests, we run something different with this kind of feature. And this basically means you're testing things which you're never running in production, which is something you should never do. So we basically try to get rid of this test class, and the correct solution to this problem is that you basically start an external Elasticsearch cluster and then run the tests against this external Elasticsearch cluster to see if everything's working as expected. And this is basically how we, or what we move over to over time. And one of the tests where we basically followed this approach is basically running our REST tests. So whenever you communicate with Elasticsearch, all you do is basically talking to an HTTP endpoint. And it doesn't really matter if behind this HTTP endpoint there's a cluster with 1 node or there's a cluster with 500 nodes. At the end, you're basically sending a request to this node and you're getting back the data you asked for, your index data. Which basically means we have to make really, really sure that this interface is what we tell you it should look like. And in order to do this, we basically created a sort of spec written in JSON, which contains all of the endpoints that Elasticsearch supports, and on top of that, all of the possible parameters. So if you take a look here, you can see a parameter called node ID, which is optionally part of the URL, and the same applies for metric. And you can also see basically what possible values are allowed, or if it's a Boolean as a type. So we kind of describe the API over this JSON spec. So what can we do with this? We basically decided that we want to not write JSON-based tests, but we want to write tests based on YAML. So in this example, this is basically a test, and we are executing a call against a certain endpoint in Elasticsearch. Based on the spec, we know which endpoint we are hitting. Then we are setting some variable from the JSON that is responded over there. And then we are executing against another endpoint. And basically, this is some sort of assertions. So we're basically assuming that a certain JSON response, that a certain field exists. And in this example, we are basically checking that a certain node name exists with another certain field. Why do we do this? We could have written all of this in Java. However, this whole test suite, so this JSON spec and those YAML tests, are basically also used by all of our officially supported clients. So basically, every client, Ruby, PHP, Perl, Python, has some sort of test runner which is able to run these tests. This basically allows us to be sure that all of our official clients also support all of the Elasticsearch features. So we basically maintain these kind of tests in the Elasticsearch repository, but we are running those tests for all of the clients. So this is basically a compatibility question. So these are REST tests. Then we have packaging tests. Basically, we create a couple of artifacts in Elasticsearch. We create a tar.gz file, a zip file, but we also create an RPM and a Debian package. And this RPM and this Debian package needs to be tested across a fair share of RPM and Debian-based distributions. So if you take, for example, the RPM, we have to make sure it's running under SUSE Linux as well as under CentOS. The problem is, if you have those long-term supported distributions, they have different startup mechanisms for scripts. A couple of them are still using System 5. Most of the newer distributions are using System D. So we have to make sure we support both of them. And with support, we always mean we have to test it. If we just think something is supported, it doesn't make a lot of sense. So in this example, we basically have a bunch of vagrant boxes configured, and we are firing up these vagrant boxes, putting the Debian package or RPM in there, and then we have a couple of files in here. This is a .bats file. BATS is short for Bash Automated Testing, which is basically a small tool which allows you to write Bash scripts as tests. So it looks like this. If you look really closely, you can see here we're just verifying with a standard command under Debian that certain package is installed. And this is how the test suite basically looks like. The interesting part with this is we can basically be sure that you can install the RPM, you can install the Debian package, you can uninstall it, we can be sure we don't leave any stuff on the file system which should not be there, and we can also test upgrades. So we can be sure that you basically have an older version of Elasticsearch installed, and with these tests we know, okay, we can install the newer version. And all of this is fully automated for all the kind of officially supported distributions. One of the problems with this Bash automated testing is that it's Bash, which basically means it's not guaranteed to run under Windows. So we are kind of thinking if we should probably replace this with something written in Java or Groovy. It's also not really developed anymore. We started to use this like 3 years ago, and since then, not a lot of stuff has changed. Who of you tests their documentation automated? 2, great. Who of you has their documentation in the same repository where the source code is, so that you basically know that this documentation is for the master branch and this one is for the 6.2.3 version? One different person, that's interesting. So at some point we kind of figured out that whenever we create new features or we deprecate features, we forget to update our documentation. So at some point, a user figured out that the documentation we have on our website is outdated compared to what Elasticsearch is actually doing. And at some point, you get so bored because every GitHub issue basically looks the same, like, oh yeah, this documentation is wrong, can you please fix it? that we decided we have to fix it and we have to automate it. So what we basically did is that all of the open source and all of the closed source projects as well basically are using AsciiDoc for documentation. And the source code snippet are basically, yes, kind of stuff missing over here. Maybe we can, let me quickly see. If we move this over here. You can basically see that there's, this is like just a regular snippet in AsciiDoc, how you define a code snippet. And this gets rendered. This is a comment. And we basically have two comments in there. The first one marks this is a snippet which is going to be extracted from the AsciiDoc and tested against the running Elasticsearch instance. And the second one is basically something like a setup call, which makes sure that a certain index exists because we're running a search operation against an index here. So it's basically like a before annotation in JUnit if you want. And this way, we're basically going through all our ASCII documentation, AsciiDoc documentation, extracting all of the code snippets and running them against an Elasticsearch cluster. And if we don't get an error back, by default, we assume this was successful. On top of that, we have a couple of other features. You can basically mark a certain snippet for test setup. So for this file, this basically means that before every test, you're basically running this piece of code. And we can also validate the response which is returned. So in this example, we basically make sure that this call over here returns this response. Otherwise, this is going to be a test failure. And this is how we make sure that all of our documentation is up to date. And this also forces the developer to basically update the documentation when they create a pull request. If they don't update the documentation, our CI will fail. So, running QA tests. We basically have something which we call smoke tests. And smoke tests is basically this whole functionality that you start up an Elasticsearch instance externally and then run certain tests against the HTTP endpoints. And because we are starting it externally, we can be basically completely free how this instance should be configured. We can decide if we only want to run one node or 20 if you have a complex test setup. And those tests are basically doing all these kind of different checks. For example, we have a feature which is called the tribe node, which basically allows you to search across different clusters and kind of unify the results. This basically means if you want to test this, you have to start up two completely different clusters and then run a search against this. The more important part are backwards compatibility tests. So we tell users how to upgrade Elasticsearch. There are two ways. The first thing is you basically power down your whole cluster, upgrade Elasticsearch, and you bring it up again. If we tell people that this is one way of potentially upgrading, we should test this. And this is what the first directory is basically for. This is doing a so-called full cluster restart. We also tell people that you can do something which is called a rolling upgrade. So if you have a cluster with 20 nodes and you want to upgrade it, you basically shut down one node, update that one, bring it up again, and do this 20 times until you have upgraded all your nodes. And again, if we tell people that this is how you upgrade Elasticsearch, we should probably test it. And this is exactly what this test is doing. So basically starting a node or starting a cluster and then going step by step while running tests against it to make sure everything keeps working. We also tell people that if you have a so-called mixed cluster, so if you're running Elasticsearch version 5.2.1 and 5.2.2, that this works, which is kind of implicit because this is exactly what happens when you do a rolling upgrade. But we also want to make sure that we don't break this claim. So we have a couple of more tests for this. And all of this just makes sure that also the different Elasticsearch versions are basically backwards compatible to each other. And yeah, on top of that, we basically have a full directory which we call QA tests, which contains a couple of different things. We, for example, also make sure that the Elasticsearch client can be started inside of an application server, because we want to be sure that, again, we don't have users telling us, look, your client doesn't work anymore, and a couple of other tests in here, but nothing which I want to go into the detail now. So we have commercial plugins. right? There's a way you need to earn some money. So at this point, I only talked about the open source part of things. But we also have to make sure that this plugin which we have and develop further is basically always in sync with the open source version of Elasticsearch. And the way we solve this is basically that we have a dedicated or a second directory where the git checkout from our commercial plugin is in. And if this directory exists, our build tool, Gradle in this example, will just pick it up and build everything, including the commercial plugin and running also the commercial plugin tests. This worked, but it also means if you do a change in Elasticsearch, which also affects the commercial plugin, you basically have to create 2 pull requests. One for the open source repository, one for the closed source one, and you have to basically push them at the same time to be sure everything gets picked up properly. This was pretty tedious, and we recently basically announced that we also take our commercial code, make it open, and put it into the same repository as Elasticsearch, which basically means it's not going to be open source, but you can read it if you want. And for me as a developer, things are suddenly really, really simple because I only need to do 1 pull request. And also our CI infrastructure becomes much, much easier. Which is something we should talk about, CI. We all know this wonderful picture, right? Everyone is a huge Jenkins fan, I assume. And this basically means that every project in Elasticsearch, so Elasticsearch, Logstash, Kibana, the commercial ones, everyone has basically their own Jenkins cluster. And I think we have a total of 120 machines across 9 clusters or something, so our CI infrastructure is pretty big. We run CI on Amazon EC2. We also have bare metal nodes. Somewhere there's also a Mac Mini, because we need to make sure that Elasticsearch also runs on OS X. There are Windows nodes, so all the machines which are being used here are really, really diverse. And we have a few jobs. This is just Elasticsearch. This is not Logstash, not Kibana. And all of those jobs, there are also jobs which, for example, in this example, test across the different Linux distributions. So just because you saw one job in this list doesn't mean that this job is not running a couple of hours if you're unlucky. What do you do with all of those test results? You index them into Elasticsearch, of course, and visualize them with Kibana. One nice feature of this for us is that we can basically search for tests. So if tests are failing more often, or if tests are failing regularly, we can easily look it up. It's also possible, we have a couple of test candidates which fail once a month, despite we're running the tests a couple of 100 times a day. And with this, we can at least look up if the error message that came up is the same. So maybe this is a test which really, really rarely fails, but we can make some sort of correlations by just looking at past test results. Yeah, if you look here, you can see that many of our builds are basically triggered by commit, which means there are 5 days of work, there are 2 days of breaks. Like whenever there's weekend, we have far less builds going on. You can also see there's a kind of fair share of failures, and whenever this gets too much, we basically just sit together as developers and try to fix tests to make sure everything gets back to a more stable cadence. And then we have this thing here. Who of you is running benchmark tests for their product? Who of you is running those regularly and automated? One, great. The same one at least this time. So we do the same. This is one of the reasons why we need to have bare metal machines, because on EC2 you cannot be sure if there's like noisy neighbors and the results are just completely random and arbitrary. But we have full control of the machines where we run those on. We also wrote a tool for Elasticsearch. It's called Rally. I have the link at the end of my presentation, which is basically running those tests and getting all the metrics out of it. And of course, you might have guessed it, indexing it into Elasticsearch. And this is basically benchmarks.elastic.co, which allows you to take a look at our nightly benchmarks. In this example, we have a couple of different data sets, which we basically run. And you can, in this example, see that we somehow did something right, because the total time it took to index the documents for this data set was suddenly cut by 10%. So at least we did some fix to increase performance, and we also see it didn't have like any negative side effects on the metrics we're measuring here. And this one here is super, super useful in general because it allows you to spot easily regressions. If there's some feature which cut down a lot of performance, it's super easy to see here, and we can basically just go back in time and like check out our commits, what might have caused this if we don't know it. So, more testing. Elasticsearch and XPack right now gets about 750 builds a day across all of the different branches we have. And each build is more than an hour. So we spend a lot of CPU cycles in CI just for Elasticsearch. We also test pull requests. So when I create a new pull request in our XPack or Elasticsearch repository, we automatically trigger a CI build. We have to test on different operating systems, right? We tell people we support Red Hat, CentOS, Debian in certain versions, Ubuntu in certain versions. If we tell people we support this, we have to make sure we run this in CI. We have to test on different JVMs. Nowadays it's a bit easier because the OpenJDK and the Oracle JDK are like very, very aligned nowadays. That what used to be different in the past. But there are also commercial JVMs. And there are some JVMs which we don't support because we know they cause data corruption. But in order to be sure about this, we have to test them. We have to test on different garbage collectors. So Java itself allows you to free yourself from memory management, which basically means there's a mechanism which reclaims memory from unused objects. And this mechanism is called the garbage collector, and there are different implementations. And the JDK developers tell every now and then that the one we use, called CMS, is going to be removed in a future release. So we have to test on different garbage collectors. There are also new garbage collectors developed by Red Hat and Oracle. And the Red Hat people, for example, use Elasticsearch to test their garbage collector, which is pretty nice. Sometimes you have to have feature branches. When there's a feature where you want to work on in a team, the pull request doesn't cut it. So we also have to make sure we test those feature branches. And of course, we need a dedicated test cluster for XPack as well, because the one I showed earlier is basically public, but the other one is not. Then we have continuous integration for our documentation. Every project has its own documentation inside of their repository, but for example, the Hadoop integration for Elasticsearch should be able to link to the Elasticsearch documentation. But because it's across different repositories, we have to make sure that like cross-references are still working. And because of that, we basically have one big job which basically checks out all of our products and makes sure that those cross-references are still working when building this documentation. And now you're asking yourself, how the hell do we manage that? And for all of the Elasticsearch stuff, we basically have something called test triage. Test triage means that every developer on the Elasticsearch team, every couple of weeks, basically has a dedicated day where he's basically just checking test failures. If there's a failure, the developer should take a look like, is it reproducible? If this is the case, then create a new issue and assign the issue to the right people. Because like with this many builds, you don't want to have everyone looking at this all the time, because then you won't be able to deliver any feature anymore. But if you, every couple of weeks, just take a look at test failures, it's usually just fine. So on top of that, of course, you need to do manual testing. On the Elasticsearch side of things, we're living a pretty luxury life because we don't have a UI. Kibana is the UI. We just have backend. And backend is usually like much more easier to test than something like UI in Kibana. We still have a small team of dedicated testers for the whole stack, working together with the developers, doing exploratory testing, lots of UI testing. But the interesting part is the cross-product testing, right? When you develop a feature where part of it is done on the Elasticsearch side and the other part is done in the UI, we have to make sure those things work together. And you start usually with manual testing and then create automated test suites out of that. And on top of that, you basically have integration testing with products that are not part of our stack, because we also have third-party integrations. So how do we release? First, we have to make sure that all of the products we want to release at once are ready. If that's the case, we're basically building something like a release candidate, and then this release candidate gets some manual testing, gets some automated testing, and at some point we say it's ready, or we say, oh wait, we have to fix X, Y, Z. And sometimes fixing X, Y, Z can take some time. Yes, longer. And at some point, we release Elasticsearch in version 5.50, as you saw at the beginning, and then we're done. The important part of this is every engineer should be able to create one of those release candidates. And the way we solve this is basically that we have a single repository with a Vagrant file and a Gradle build. And you basically only need Vagrant and VirtualBox installed on this system. And the Vagrant image itself installs all the required parts of the technology zoo you saw at the beginning. So the person triggering a release doesn't need to know about the concrete build steps or anything else. And the important part of this is that this tool builds our product, creates package repositories, also signs the packages, which you need to be done for the Debian and RPM repositories, for example. And the result is important. The result is something which is called an immutable artifact. What you don't want to do is you create a release candidate, you test this release candidate, and then you say, oh yeah, this testing was so great, now I'm building the artifacts for release, because you have no idea if something has changed in between with the number of projects we have. So what happens here is we have those immutable artifacts, and if we say at some point in time, we are now ready to release, we are releasing those which we created at this point in time. We don't trigger a new build or anything like that. Which brings us to the release. That's it, right? Because we have everything in Gradle, we basically just need to run Gradle Release, and that basically uploads the artifacts to the correct locations. We have certain numbers of staging repositories, which then get published and so forth, and we're done, right? Well, it's not that easy. Not everything is automated as part of this release. And you have a couple of things which are not really easy to be automated. Documentation, for example, is something which is decoupled from a release. If I fix a typo in the documentation, which is part of the Elasticsearch repository, I want to make sure that this one is on the website within an hour or two. So it's completely independent from the release, which basically means documentation gets continuously built and published on our website. Then we have all these little tiny things like publishing blog posts, updating website download links, creating forum posts. Post-release work needs to be done for some projects. So in Elasticsearch, for example, we have to update a certain Java file, which then basically triggers new CI builds and downloads new snapshots for the backwards compatibility testing. So there's more to it. And you also shouldn't forget to put your product's end of life, right? You don't want to support software you wrote 2 years ago. Because if you do, you kind of stop developing features because you're busy doing maintenance. And with the stack-based release, so the first 90% is basically which version was compatible with what. And now we can basically tell people like, look, our whole stack is going to be unsupported at this date if you're using that version. And that simplifies things a lot for us. So, just a quick summary. One of the things I usually want to talk people in when giving this talk is that you need to make sure you create those immutable artifacts, because I think this is something we're usually super weak with. We just create a build and then we create another and we hope they're kind of compatible. And that's super dangerous, and we did that for a long time as well. If you decide to automate your release, do it as early as possible. We did it super late when we already had this technology zoo, and it took us like 2.5 months to come up with something useful until we finally had this one repository which built everything and uploaded everything. So it's not easy. This is super important. Don't create bus factors. You usually do this already a lot when in development, but you really don't want to do it when releasing, because this is the moment when your software hits the public. And if you only have this one person doing the release and they can't go on holiday and they can't go skiing, because otherwise when they fall, you can't do release, it's super bad. And all the non-technical aspects are much harder to automate, like this blog post thingy. Your CMS should be automatically publishing things, creating a changelog properly. That suddenly gets much more complex, or blog posts just highlighting releases. And yeah, the last and most important part over here is does this work for you? I don't know. One of the things here is we have a product. If you're running something as a service and you can just do updates all the time, you usually don't have to stick to any of those things. You can just do something in the background, have a canary release which basically gradually switches over to your new branch, which is super useful. But if you have something like this, where you basically have to ship software to your customers, you have to be super careful when you say, like, this is it, this is the moment I'm shipping things. And that's where you have to think about all of these kind of things. Is this perfect? Absolutely not. It currently just works for us. We saw where it's super painful, like when you have, for example, our commercial plugin and the open source repository, and we need to make sure like everything works as expected, but we can only make changes gradually, or we have to create two pull requests. So if you can prevent this, go ahead and do it. Which basically brings me to the end. I have a couple of links, which basically are mostly the CI environments. This is the link to our benchmarking tool. If you're more interested like in how we also do all of this team scaling, because having a company, when I started, we were like 30 people, now we're more than 800. This also means we have a couple of hundred engineers, and like scaling this and making sure everyone works together is super, super hard. And this talk just covers a couple of things, how we did it on the non-technical side of things. And yeah, last but not least, thanks for listening, but I really would like you to give a round of applause to our translators, because I've never seen this at any other conference, and I think it's super, super awesome. And they have like this not awesome job sitting in this non-air-conditioned box all day and like listening to rants of people. So I would like to have a round of applause for the people translating things over here, and then we can open up questions. I'll be also hanging out here after the keynote, so if you just want to rush over the keynote, just do it. I'll be here all evening long until it closes. If you have questions, I think I'm just going to hang out after the keynote. We get to that. No rush, please. If you have questions, you can also just meet me at the couches where the keynote is. On top of that, this is a QR code for the slides, but I also tweeted about it. And we now have to check out Slido, I heard. So, first question, as I understand, you don't have automated test of UI. We don't have automated test of UI in Elasticsearch because it doesn't have one, but we have automated test of our UI for Kibana. It's just not something I have talked about because I'm the Elasticsearch backend developer and I have like the UI skills of a 3-year-old. So this is why I didn't cover it, but Kibana has a ton of UI tests which are also automated using Selenium and Source Labs, for example. Reindexing Elastic is very painful for testers. How can I optimize it? If you come back to me and tell me what exactly is painful, I'm super happy to help. Obviously, I'm super biased, and if I stand in front of you and say it's not painful, this won't solve the problem. So whoever wrote this, and if you can just explain what exactly you're meaning with this, I'm super happy to help. If you want to just cover it later on, it's fine. And if we have a couple of questions for the audience right now, I'm all ears.
I can ask one.
You can't, you're not, I can't hear you.
Can you?
No? But I can repeat the question if you want.
Should I do it this way? Without me?
Yes.
It's more about programming, but not about testing. So, shall I?
Yes, go ahead.
Normally Elasticsearch used from the side of backend, but you have a client library for the frontend on your GitHub.
Which client library are you referring to?
A JavaScript client for Elastic. And many of us developers, they think that using Elastic from querying Elastic from frontend without backend layer is a security pitfall. And could you expand on this?
Okay, so the question is, first thing is, one of our client libraries is a JavaScript one, which is also used by Kibana, because Kibana is a tool written in JavaScript. And we also tell people from a security perspective, you should never ever like expose Elasticsearch to the internet or query it directly. And this stands true. You can use this client library in the browser if you want, just because we wrote it that way. We are still not recommending you exposing Elasticsearch to the internet if you haven't like either using one of our commercial products called XPack Security, which allows you to protect it, or if you have basically some sort of layer in between which shields the Elasticsearch instance from the outside world. Because as everything, You also don't put your database outside into the internet, and you should not do the same with Elasticsearch either. Where your data is something which needs to be as secure as possible. Did that answer your question?
Yes.
Awesome.
I will ask another alpha later.
You can ask another if there's no one else asking questions.
Okay. So if I'm on a stage of MVP or if I'm on stage of promo and I want to move fast, like agile, and I'm using Elastic as a query storage where I do autocomplete mainly. So basically I'm just reading from Elastic and I'm not doing something trivial or complex inside Elastic, and I'm just browsing and reading it, and it's storing pages of like blog posts and so on. So what is the point having a layer on top of it? Is if I can penetrate layer, I can penetrate Elastic, but it has just data to be queried from.
So I think the main question here is, what sense does a layer make if your query is super simple? I think the most important point for this kind of layer, which I was also just referring to, is security. But if you can make sure that you're only querying Elasticsearch from a read-only perspective, you might not need it.
So to summarize, if I'm just reading from Elastic and there's nothing specific in it, I can skip this layer security one.
As long as you can be super sure that people cannot write to Elasticsearch, and this is something you still have to cater for.
Thank you.
All right. What is the timing telling us? 2 minutes. Awesome. So you're basically getting back 2 minutes of your life by heading over to the keynote. If there are no further questions, otherwise just come up after the talk. And yeah, thanks for coming by, and enjoy the rest of the conference.